In this video, we're going to talk about slope and similar triangle concept. Again, it is a concept that we have worked with in class. I have mentioned this. You have seen me do very specific type of labeling before. So as you go through this video, you should say, oh yes, I remember. Yes, Miss Hendricks said it would work as well. So what is this concept all about? Let's do some investigation. We have Joe and Kelly each going to find slope of the graph shown by comparing the ratio of rise over run. Okay, so what they're doing is both students are doing their own thing and they're trying to see if they come up with the same answer. Okay, so we have Joe is using 2 points on the graph. So he's using 0, 0, and then 2 and 4. So these are the 2 points that he's using. Okay, so when we determine the slope, okay, so our rise and run. Joe's slope was 4 is his rise, 2 is his run, the slope is 2. Well, Kelly is doing something different. Her points are not the same. So I'm going to plot her points. Her points are 2 and 4. Okay, so she's using this point. So I'm just going to put an X right here. And then 5 and 10, all the way right here. Okay, so when I am evaluating Kelly's 1, 2, 3, 4, 5, 6. 6 is my rise, and then 3 is my run. So that tells me, oh, well, it's the same slope. Okay, so what we are just highlighting and making sure that we totally understand, when we have these triangles and we get the same slope, that means your triangles are similar. So we did similarity work first semester. We would line them up in a proportion. We're going to compare, reduce them, and so on. So that's what is coming back into that slope topic. They are proportional. Proportional. Okay. So your ratio of rise over run will be the same. Okay, so when I say rise and run, I also want to say that your rise and run is the same as your height and base. So let's talk about this. Hope it's not a little confusing. Let me zoom in on the second or seventh question, and we're going to talk about this one more time. It says, based on what you know, which of the following triangles will also lie on the graph, on the line graphed above? So here's what I really want for you to consider. When we look at these triangles, all of these triangles look identical. So we cannot trust the picture. So sometimes when you're like, oh no, it doesn't look like it could work. Well, you need to put the numbers to work. Okay, so again, what we're going to do is we're looking for the ratio of 2 to 1, and we're going to line up these triangles to see if they can fit this ratio, simplify to this ratio. So when we have a graph and we're doing the slope, it all kind of makes sense, rise and run, and so on. With a triangle without the graph, it might look really interesting and really bizarre. Well, it's not rise and run. This looks like a nice little right triangle that has a height of 26 and base of 14. Height of 36, base of 18. Height of 30, base is 12. So your rise and run are the same as rise height of your triangle. Your run is the same as base of your triangle. I am really want for you to be really careful with that, because, and I seen it earlier in our practice on Thursday, you had some questions where your triangle was positioned this way. And I think it kind of really confused you. Remember, this is still the rise, this is your height, and this is your base. So this is your rise. It was rising these many units and then running. Okay? So a little bit of a different approach, but your relationship still has to be done in correct order. Rise over run, rise over run. All right, let's see. 26 over 14. Nope. 36 over 18. Yes. 30 over 12. Nope. So only triangle B would fit this slope ratio. All right, let's take a look at another example. Let's break this down. Let's break down this process one more time. It says, draw two different triangles that could be used to find slope on the graph below and label rise over run and explain the relationship. Again, I still would like for you just to kind of work with me on this and follow my lead. You might say, there's no dots. What do I use? So huge reminder here for you guys today. Let me zoom in some more on my graph. Is to make sure that you are working with the numbers that are easy to read. Easy to read. So these are perfectly positioned dots. Okay, these are the dots that I'm going to be using. Again, I'm not using this green dot. Hopefully you can see the difference in color here a little bit. This is my green marker, this is my purple marker. Okay. So my rise and my run. Do you notice anything special about those numbers? We talked about these on Wednesday. So pay attention. Sometimes your scale might be not going by 1, 2, 3, 4, 5. This one is going by 2. So the actual slope here, the first slope that we see, is 4 over 3. Not 2 over 3, but 4 over 3. Okay? So then what I can do, I'm going to just use different little highlighter, little marker. I'd say, well, what if I started at the origin and did this large triangle? What would that be? Okay, so my rise was 8. My run was 6. All right, looking good, looking good. Let's see if I can do this one more time. All right, so I'm using this little point. So as you can see, my pattern is there. So I have risen 12 units and my run was 9. 9. I don't know why I'm writing 8. 9. All right, so from here, do they all reduce to 4 over 3? Yes. Okay, so this is the concept of those similar triangles that all lay on the same graph. They all bring you the same result. So I could have started with the larger triangle and saw my small triangle later on. So the values on the graph will not matter as long as they all reduce to your slope at the end. So slope for this particular graph is 4 over 3. All right, question 9 is very similar to earlier question 7. I like that we still have a good set of numbers that we are working with. Let me zoom out a little bit. It says, which of the following triangles will also fit the line, will fit on this line that you are seeing? So here's the challenge. We cannot plot these triangles right here. So our step number 1, we need to find the slope of this graph first and see which of these triangles will reduce to our slope. So we have a negative slope here. Our line is falling. So I'm going to use my y-intercept as beginning of my graph. And so my next graph that I am using, or next value, let's see, this looks good right here. Not making it very large. So here's my little triangle, and my ratio is 2 by 3. 2 by 3. So remember, guys, this is your fall, okay, it's your height, and this is your run. 30 by 55. So if I'm trying to get 2, I would say, oh, well, 30 divided by 15 is 2. But 55 is not divisible. So it doesn't work. Okay. So 28 by 45. Oh, as you can see, yes, I can do 45 divided by 15 is 3, but this is the top number does not work. But example C, look at this. 26 divided by 13 is 2. 39 divided by 13 is 3. We know we are falling. So I know it's the height and the base, but we are falling. It's a negative slope that will reduce to this number. So triangle C is your correct triangle that fits this ratio. All right, so I'm going to stop right here. I feel that you have plenty of examples to try out. Couple of, or not couple of, but quizzes practice. Again, keep in mind, your ratios of your triangle all have to reduce to the same amount. If you see in triangles, no matter how they're positioned, you need to make sure that you do your analysis. Am I rising and running, or am I falling and running? Start with, is it positive or is it negative? So please take time to practice on quizzes, set of questions, and please let me know if you have additional questions.